We're going to start the unit of trigonometry. Trigonometry is a lot more than what you think. We start off with basic triangles, and that's how we start this off, triangles. And then from triangles, we parlay this into the study of angles. So with the study of triangles and angles, in grade 12, or 11 and 12, you really start studying the wave phenomena. All of this starts with the basic understanding of triangles. So a basic review of trigonometry is, number one, you have to ensure that your calculator is in degree mode. Otherwise, you're going to get a lot of nonsense out of your calculator. So I'm just going to save you the trouble. One property of triangles is the sum of all angles is 180 in a triangle. So all angles in a triangle add up to 180. So for example, for number 3, find the missing angle. What is B? Well, as we could see here, this is not a right triangle. Well, it doesn't really matter. We can find out B, and simply 62 degrees plus 91 degrees plus some angle B is equal to 180 degrees. Or, as a lot of you have discovered, is that if you just subtract the other two angles from 180, you'll have your resulting angle B. Now, I would criticize this, calling this angle B, simply because it should be called B. Generally speaking, we call angles uppercase. Sides generally are lowercase. So in trigonometry, if we ever have to deal with an unknown angle, you might see it described as theta. So we're labeling a triangle using letters, and when we label a triangle, you never have the same letter and the angle side by side, the same letter side by side. But I'm going to maybe reach into this a little bit deeper. Suppose that I have triangle, now I would call this triangle LMN. How do we label this triangle LMN? Well, what we see is that the upper cases are in the corners. So I can talk about angle M, angle N, and angle L. All of these are angles, and it's implied that they're uppercased, so there must be angles. Well, how do you label their sides? Well, their sides, side L is directly across from angle L. Same with N. Last but not least, you probably guessed that M is directly opposite, side M is directly opposite angle M, and angle M is directly opposite side M. So this naming convention is really important because if you don't have this down, it creates a lot of issues. Now, using very similar reasoning, the angle G is directly opposite side G. Angle F is directly opposite side F. Angle H is directly opposite side H. So as I have defined this, this is triangle FGH. So for the technical names of sides of triangles, specifically we're going to look at right triangles. We have to pick an angle theta, and I'm just going to maybe explain to you how I would label a triangle. I notice this is a right triangle. It is a right triangle because it's a square. Now this square implies that it's 90 degrees. You have seen this many times before. So what do? We pick one of the non-right angles and we call it theta. Now theta is the unknown angle. Now it's with respect to theta that we label our triangle. The longest side is always called the hypotenuse. Now I should qualify that the longest side of our right angle side is also called the hypotenuse. But more exactly, the hypotenuse is the side that is directly opposite the right angle. Now, I'm going to label my triangle. So the longest side is called hypotenuse. And I don't know exactly how you spell that. I think it's good. The side that is across from theta is no, I don't like that. How about this? The side that is opposite theta, why don't we call it opposite? And you'll often see instead of opposite, I just write OPP. Now, well, that was fairly easy. The leg or the side that is connected to the angle that we pick. So if this is theta, what is the last side called? Well, the last side is actually called the adjacent. And the reason why we call it adjacent is because this is the side that is adjacent. All adjacent means is beside or next to. So for example, my neighbor lives adjacent, or it lives in the house adjacent to mine. It's the house beside mine. So in this other example here, well, I'm just obviously jump straight to my hypotenuse, easiest one to pick out. And then I identify where my theta is. If this is my theta, this must be my side opposite theta, and this is my side that is adjacent to theta.